Hello, welcome back. Today we're going to discuss C# collections in general, and this will bring together our discussion of the C# list type and object-oriented design principles in general. It'll help us understand and read an object hierarchy, one corner of it, but when you understand this corner of it, I think it'll shed a lot of light on how to read the entire object library, which, as we know, is a large hierarchy in descending from the object class. So remember the four characteristics of an object-oriented programming language: encapsulation, inheritance, polymorphism, and abstraction. These characteristics are well on display when we look at the C# collection hierarchy. So here's our type collection of the generic collections. We have IEnumerable at the top. Notice it's an interface. Then stack and queue are off to the right. iCollection, iList, and then the four classes that inherit from those, the four concrete classes at the bottom: the hash set, list, collection, and linked lists. We'll go through each of these elements in turn, starting from the top, IEnumerable, and we'll look at the details of what each of these bring to the table. So the IEnumerable and IEnumerator. So the IEnumerable T promises one thing. So it's an interface with one method. That is, you can get an enumerator on it. So the enumerator is where most of the action happens. That allows you to get to the current place, move next, reset, and this allows collection traversal. In C# programming, you'll very rarely use IEnumerable and IEnumerator directly. However, the for each loop depends on each of these under the covers. So they are used anytime you use the for each loop, or if you want to engineer a class that can be enumerated, you need to implement these interfaces. Again, this is at the top of the hierarchy. Taking a look at here, it enables traversal of the list. Next, we'll look at the iCollection. So the interface iCollection, this is essentially the heart of the collection. You can look at the methods that it makes. Does it contain, add, remove, clear, copy to, count, is read-only. Essentially, the basis of the collection itself is expressed in the iCollection interface. So, IEnumerable, the ability to traverse the interface, or traverse the collection. iCollection, the heart of the collection itself, the collection of items, how to add and remove items from the collection. Next, we'll see what iList brings to the table. So the interface iList adds random access to the elements like the basic array. So random access means that any element can be as easily accessed as any other element. So element 0 in a collection is as easily accessed as element 10,000. And any time you see random access used in a computer lingo, that means that any element can be as easily accessed as any other element. So notice it offers the array index through brackets. It has the index of, finding an element and returning the index of it. It allows you to insert at an index place and remove at an index. So the iList gives us indexability, like a basic array, to our collection. So IEnumerable, able to traverse the list. iCollection, the basic elements of the container. And iList, random access. So here, we're going to discuss the classes collection and list. These are our first concrete classes. They inherit. They're our first classes. The collection class adheres closely to the interfaces. It's easy to specialize. So, for example, if you have an animal farm, is a collection of animal, whereas the list offers elements beyond the interfaces. So you take the interface, which remember is a promise that will implement those methods, but list goes beyond that, allowing sorting, searching, reversing, and conversion operations to the basic interface elements that we inherited from. So again, IEnumerable, iCollection, and iList, and list and collection both inherit from that. Notice we'll discuss linked list next. Notice that linked list is not an iList, but it is an iCollection. And the distinction between collection and list is that collection adheres closely to the interface, whereas list adds methods that are beyond what is promised with iList or iCollection or iEnumerable. Okay, so this is linked list implementation. So if you think about, let's go back a bit to the list and collection. Internally, those are dynamically growing arrays. So you have a block of memory, and then when you add to the block of memory, if you exceed the current memory requirement, the memory that's been allocated for the list or the collection, then that block is grown and the existing block is copied down into it. The linked list, instead of being a block of memory all in one big chunk, is individual pieces that are linked together. So we have a singly linked list with the head and the next pointer. Essentially, a pointer leads to the next element, next element, next element. So instead of thinking, let's say, of a block of memory that have been allocated all in one chunk, the contiguous piece of memory containing your collection. The linked list is individual pieces of the collection, individual items in the collection that are linked one to the other. They're not necessarily followed. They point to one another and they refer to one another. So think of that as kind of a loose linked list. It's like a chain of things. So the advantage of them is that you can insert at the beginning or in the middle relatively cheaply, whereas when you insert at the beginning in the middle of a list with its monolithic block of memory, that means the entire memory block has to be moved down as a chunk. So linked lists sometimes more efficient for some operations, but most of the time lists are used, and lists because you just add to the end, and that turns out to be more efficient than a linked list. But linked lists, especially the doubly linked list, has some advantages for adding in the middle and at the beginning of the list. And it doesn't prefer the beginning or the end of the list particularly. So here we have again, notice the linked list, what it lacks. It's not an iList, and remember what iList has. iList allows random access. Linked list, so in a linked list, let's suppose you have the first element in the list very easily accessed, first element of the list or the last element in the list. But what if you have the 10,000th element in the list? You need to traverse the links 10,000, essentially 10,000 times to get to the 10,000th element. Therefore, not a random access collection, and that makes sense if you think about the physical implementation of the linked list. Not a random access collection, so it doesn't have the iList interface. In our next lecture, we'll discuss the stack and the queue, which are here. They're iEnumerable, but not they don't inherit from the collection type.